Good morning, good afternoon, good evening, everybody. My name is Arthur Hicken. I'm the evangelist at Parasoft. With me today is Brian Knuckles. We're going to be talking to you today about getting started with static analysis. So should be pretty interesting stuff. Just a couple of housekeeping things in the beginning. We are doing this in multiple time zones and at multiple time slots. So pay attention to this. We have a Q&A box. If you have actual questions, please put them in the Q&A box so that we can answer them when it's appropriate. We might answer them right as it comes, but we might answer at the end, even if you end up on a rebroadcast session, because I don't like doing webinars at 3 a.m., but if you end up on one of those, we still have people monitoring. So the agenda today is getting everything right with static analysis. It's making sure you have the right checkers, the right code, the right findings, the right people, and really running static analysis the right time in the right place. And you're going to see that this isn't actually as hard as it could be. So a little background, of course, security is a #1 concern for people. Regulation is here, more regulation is coming. We have things like GDPR around privacy, PCI-DSS, HIPAA. California's got a new Privacy Act. Other jurisdictions are following as well. So there's a lot of things that make security an important part of static analysis. So we like to kind of lump them together when we talk about static analysis, because the basic thing is that what people are doing today isn't really working. So let's look at what we should be doing. Here's a basic DevOps workflow. I put DevSecOps because honestly, we all should be concerned about security. So we have a bunch of developers working away. We have an architect or lead who creates a static analysis configuration, and then it gets shared back to all the different developers as well as to the CI build system. And this is super important because one of the mistakes people make is they'll grab a bunch of arbitrary tools that don't have any enterprise support, and it's hard to keep the configuration up to date. If you've got 5,000 engineers and you go and you have to redeploy a configuration to every single developer desktop, it can be very problematic. So Parasoft, obviously, we support this live instantaneous sharing, and you'll see it as we go through some of the demos later today. Also, yeah, source control, and I mentioned here pre-commit and post-commit, and we'll dive into some of the benefits of both of those models as we go forward. So out of the CI/CD system, you should be getting reports. And the interesting thing is that different data is necessary for different people. Again, we'll dive into that during the demo part, but the managers and the leads and the compliance officers all need, dashboards, charts, histograms, maybe specific compliance reports. Again, the actual people writing the code need that information right in their desktop, in their IDE, not in an email, not in a spreadsheet, but actually where they write code so that they can fix the violations. So let's look at the first things first, making sure that you have the right checkers turned on or rules. I have to say that we've been doing static analysis here for a long time, and we used to always call them rules. So if Brian and I say the word rule today, you can just assume that what we really mean is checker, okay? And that is that a checker is an instance of a static analysis thingy that will check for a specific kind of an issue. So what checkers should you turn on? Well, you might have standards or compliance needs. All these little boxes at the bottom at the right, all these different standards require specific static analysis checkers to be turned on. And it's important, if you do have a compliance need, that you don't simply get a tool that says, hey, I support OWASP, and it turns out it supports 3 of the 10. So making sure if compliance is the reason you're doing static analysis, maybe it's MISRA, you're doing automotive, maybe it's UL 2900, you're doing IoT, make sure that the static analysis tool actually covers the full standard. The next thing you look at beyond just compliance needs is, what are you trying to do? Why are you running static analysis? And I know this seems kind of crazy, but it's an important question, because if we have an outcome in mind, we have a much better chance at succeeding. So the three most important things that I look at in trying to choose a static analysis checker is to say, well, I have things going on. Maybe it's application crashes, performance issues, security vulnerabilities. Maybe it's too much tech support going on. And so I look at what are the problems that are actually occurring in the field, what kinds of code, what kinds of static analysis checkers would hopefully at least have an early detection for these things before I deploy, or better yet, would actually put in place some kind of a coding standard that would completely prevent the item from occurring in the first place, like a SQL injection. Things happen in the news. That's another thing. This is a constant issue. I have all kinds of cybersecurity news alerts, and it's enough to flood you. Like, I literally don't have time to read them all, even to read the headlines for all of them. But there are things that constantly happen in the news, SQL injections, data breaches, IoT hacks, password leaks, things like that. So I would certainly make sure that my organization didn't end up in the news in one of these things that all my competitors are. So it's an important thing. And then things you worry will happen, because so far both of those other are very reactive, right? I'm saying what's happening, let's make sure we're dealing with it. From a proactive sense, I want to say, what do I worry about? If I'm building an application for first responders, performance really matters to me. Reliability, availability are all extremely important. If I'm doing a medical device, then safety is super important to me. So you have to think about the context of what you worry about. And we'll show you some interesting ways to do that. But first, what I want to do is take a look at checker selection itself. So Brian, we can start you up here.
All right, hello everybody. So what we're going to start off with here is our test configuration editor. And essentially this is inside of Parasoft DTP, which is our central reporting and analytic server. So any test configuration you run with all of your checkers on your source code is reported here and kind of aggregated into some top level views. But what we're going to use test configuration editor here for is to get all of our right checkers. So what we're looking at right now is a CERT for Java test configuration. So this configuration has all the checkers needed for the CERT standard for Java applications. We also have a whole bunch of other pre-built test configurations for other standards, our other supported languages in C++ test and .test, but we're going to focus here on CERT for Java. And what we see here in this test configuration are a whole bunch of different checkers that have been enabled for analysis. So if you click into any of these checkers, we get a whole bunch of good information down below about what the checker does and how it performs its job. So if you're ever wondering, is a certain checker relevant to me or my application, my organization, or why should I use a checker? Where does it come from, and how has it been validated? All that information is going to be here. So every checker is going to have a simple description. Every checker will not have parameters, and we'll get into that in just a minute. But you can see benefits, and there's even some drawbacks because some checkers can conflict with each other. Maybe they're looking for opposite syntaxes on certain lines, that kind of thing. Every checker will have a code example as well as a code repair for that example of a given violation. And down here at the bottom, we have a lot of good information, and in this case we have a link to a video which will kind of show context for the checker and actually provide some training and some strategies to write your application in such a way that this violation of the checker will never appear in the first place.
And this is a really great thing, because one of the problems people have with static analysis is that sometimes they don't fully understand why a checker fired, and they might even wrongly call it a false positive. And it's because they don't understand, why is this particular checker important? What does it represent? And what are some strategies for dealing with it? Because sometimes you go, this looks like the only way I could write this piece of code. So this training that we have in some of these specific areas can be very, very helpful for your learning and really overcome that knowledge problem that some people have.
Yeah, it's super useful. And like Arthur mentioned, not every checker is kind of what it seems on the surface. And over here in parameters for this checker, we can see why. Turning on a checker, it's meant to be enabled and run and check what it's supposed to check, but a lot of parameters are available for some of these checkers. Say, for example, this checker that we're looking at is looking for reflection in classes. And it's checking for all of these different regular expressions within these classes, and it may fire a violation on any of these. Um, let's say, for example, we don't care about most of these, right? This checker is looking for a lot of different things, and maybe we only care about the get methods that are involved with reflection. So what we can do is go in and disable all of the other syntaxes for this checker, and now we've kind of trimmed the fat of maybe dozens of extra violations that maybe we really never really cared about. This is okay for our application. We just care about this get call.
And this is really cool because, we titled this section "Getting the Right Checkers." I could almost title this feature "Getting the Checker Right," because what Brian's done here is fine-tuned the checker to be the things that he cares about rather than things that someone else cares about.
Yeah, exactly. And it can even go in the opposite direction. We can add a parameter here, say that's something that's specific to your application that you need to look for. It is a default in the checker, so that can be added as well. So it's all very customizable. So this is kind of on a micro level. On a macro level for our CERT for Java configuration, we of course have all of the checkers enabled for CERT, right? We're checking against the CERT standard. But maybe that's not enough for us. Maybe that's not enough for our team. Like Arthur mentioned earlier, security is a big concern. And since all of our checkers are in categories, if we want to add some security measures, we can scroll down here to security, show all the rules that aren't enabled, and we can kind of go through here and cherry pick some of the security rules that maybe are important to our team that the CERT configuration didn't already have active. We'll save that. And we can even go further and we can look for maybe specific bugs that we're worried about occurring in the application. So maybe we're worried about null pointer exceptions. We can go ahead and search all of our checkers for some rules that might check for null pointer exceptions. We've got some CWEs. We've got a couple OWASP rules that we can add to the configuration to check for these kind of things. And then a big thing that Arthur mentioned earlier was people are always worried about SQL injection attacks, right? So we can go ahead and search for any rules that have to do with SQL. And we already see there's a couple CWE rules here that protect against SQL injection. So we'll go ahead and enable these. And then kind of just in a few clicks and a couple minutes of searching for what we wanted to add to this configuration, we've enhanced our CERT for Java test configuration. So now we're looking for things that are important to our team and important to our application.
And this is a really great, effective thing for people to do these days, right? Because a lot of organizations look at quality, safety, security as orthogonal behaviors. And what we're saying is that you can tune your static analysis so that it's taking care of your safety issues, your standards compliance issues, your security issues, and whatever else that you're worried about, all roll it into one nice little configuration so it's easy to deal with.
Exactly. So now that we've enabled the right checkers for our application, we're going to make sure that we're going to be running this test configuration on the right segments of code and make sure we're getting accurate results for our means.
Yeah, so let's go back to our slides here. Getting the right code. So the mistake that people make is that sometimes they just run static analysis on everything they have. And the truth is that most of us don't have the luxury of running on greenfield, meaning everything we're written is new and it's fresh. We usually have some amount of legacy code. And we're going to talk about what does that even mean, legacy code? It's a pretty funny conversation we'll talk about in just a moment. But when I say getting the right code, I also think about not all code is as important as other code. Some modules are extremely critical. Maybe again, their safety or accuracy is super important. Their reliability is important. Some modules get called over and over and over and over again, and so they can create denial of service entries or other kinds of stability or performance problems. And sometimes I even want to do some form of a variable configuration. So it might be that I implement static analysis in phases. Maybe my final result is going to be that I've got to turn on 150 checkers, but today that's just too much work. So I'm going to create configurations where maybe all the most critical, important things sit in my phase one. And as we bring either modules or teams or applications into compliance with phase one, we'll move on to phase two and maybe even phase three. Also, there's interesting ideas around what you execute on the desktop versus automation. And this is a pretty interesting discussion because it can go either way. It might be that I simply run the same thing everywhere. In the desktop it runs, in the automation it runs, and it's always the same thing. And that's certainly the simplest. But for practical sake, it might be that I want to run a few more checkers on the desktop, ones that I'm not going to use as a gate during automation, but that I want people to look at. These might be inspection rules, these code smells, the things that I want you to look at, but again, I can't use it as a strong gate. It's just something I want you to think about when you're writing code. So I might have a stronger set on the desktop. Conversely, it might be that I've got some big, really nasty, really cool, intense, global level deep analysis running that just takes forever, or it takes more of the application than I have on the desktop. So again, looking at your organization, your needs, you have to decide what's the best way to go forward. I typically prefer also, when I think about desktop versus automation, a trust but verify model. And we'll talk about that more in a moment. But in essence, some people think that they should be using static analysis as a blocker for the check-in or for executing the next phase in a CI process. And I worry about adding blockers to the development process because static analysis can produce tens or hundreds or even thousands of violations and become a real problem. So by trust but verify, what I say is I expect developers to run static analysis on the desktop and fix the things that are there, but my automation is where I'm actually measuring it. So that's my verification of what they did. And this is a nice way because I don't have a blocker, but I'm sure that the right thing is being done all the time. So I wanted to talk about legacy because when I was having this discussion the other day with one of our solution architects, I said, well, legacy code is old code. And he's like, that's not what it means. It's not what it means to me. And as I started to put the slide together, I realized that when you Google legacy, it doesn't mean old. It's typically like a bequest that you get from when someone is gone. And this is pretty interesting because legacy code usually does mean that someone is gone. Sometimes it is your old ancient code, but more often it means something very, very different. And the funny thing about a legacy is that it can be wonderful. It could be that my great uncle that I never met left me $1 million, or it could be something that incurs some form of a long-term debt, like a bird that's going to outlive me and needs medical care. So legacy code is the same thing. It might be simply old. It might be that the person who wrote it is long gone. It might be code that no one understands and everyone fears. Almost all like long-term applications have that module. You know what I'm talking about. That piece of code that no one wants to change. Everybody's nervous. If you find little problems in it, you're super, super hesitant. Some organizations even have policies that certain pieces of code cannot be touched unless a field bug has been filed so that they don't have risk from change. So it's pretty interesting, and there are different things you can do. On the most extreme end, the thing is to bring old code into compliance with new code. But again, you're changing it and it's working, so it's dangerous and time-consuming. Another model is to say, well, we're starting this project as of April 1st, and so all code written after April 1st is going to follow this really cool set of checkers. And code before April 1st, maybe only on lines changed since then, or maybe when we change a line, we open the whole file up to being fixed. So there's a lot of different policies and thoughts that you can have about how to address your legacy code. Probably the least effective two are, one, to simply ignore it and presume that it's safe, or two, presume that it's the same as new code and try and fix everything in it. So let's take it some looks of ways that we can deal with different forms of legacy code.
All right, so what I've transitioned to here is our Parasoft JTest tool running inside an Eclipse style IDE. And I've got open our Parabank project, which is what we use to test internally quite often. And what I've done with this project, I've already taken that CERT for Java test configuration that we just created, and I've run the entire configuration on the whole project. And what it's come back to me with is 1,340 findings. So this huge mountain of findings that are been reported from the entire project, right? So if I'm just a developer, I'm at my desktop, and this is what I get back. I come in on Monday morning, run the scan on my project, I get 1,340 violations. That's a huge amount of findings that I'm not going to be able to work through this all in a day, maybe even a week. So, I mean, maybe what they might try and do is, I don't know, start at the highest severity, the most important violations, and start working their way down the list. But even then, we can't guarantee that all of these violations are important to that developer. Maybe some of them are from a segment of the application that the developer doesn't usually work on. And maybe a coworker is going to run a scan on that section and fix their own violations on their own. Maybe some of these high severity violations are from a segment of the application that is legacy, right? Maybe if they go in and fix some of these high severity violations in that segment of the application that is very high risk to change, or nobody really knows how it works since a developer left, that's really high risk, right? They could break something and the application could cease to function properly, right? So as a single developer, how do we get past this? Well, what's important to me, right? Let's say, for example, last week, I was working on the component of the application called Bookstore. I changed a lot of files. I checked everything into source control. I don't really remember what I changed from last week because it was last week. And I'm here on Monday and I need to go fix the violations that come up from my scan. Well, what we can do then is heading back to our test configuration editor, we have a whole bunch of filters for scopes that we can add and modify to get the results that we want to get from our static analysis run. So we can set filters based on time, we can set filters based on file path, authorship, and a whole bunch of different configuration options that we can use so we can ensure that our results are something we want to look for. So we said we were working on it last week. So what we're going to do is we're going to check files that were modified within the last n days, and we'll set that to 7 days, right? We also know that we were working specifically in the bookstore section of the project. So I'm going to give it the file path for that bookstore component. So once I save this test configuration and head back to my IDE, when I run it again, I should be getting results that basically they're the only ones that I care about.
And this is really cool because what we're doing here is we're not moving on to a triage process yet. We're not doing a lot of manual effort looking at results and trying to decide what's important. We're focusing on getting everything set up right so that we're minimizing the number of results that I end up having to look through and decide what do I need to fix.
Exactly. So it's a much more quicker run than our 1,300 findings run, I can tell you that. And we can see that we have 70 findings reported at the end of our analysis. And if we look through them all, we can see that they're all part of the bookstore component of the application. So it's pretty safe to say that we can guarantee that all of these findings now are something that I have interest in and that I have knowledge of that I can fix, right? We took it down from 1,340 findings to almost 5% of that original number. And as a developer now, this is where you can kind of start triage processes, right? You've got maybe 10, less than a dozen severity 1 violations, which, yeah, you can chunk through those in a day, get those out of the way, and kind of shore up any faults or bugs that may have occurred in this segment of the application that you worked on last week.
Yeah, that was really great, right? Like, again, you said something important there where basically you got rid of 95% of the things that you were going to have to sift through. Like that is an enormous savings.
Mm-hmm. And this is just kind of at the developer level, really. this is what you see on the desktop, and we're going to see here in a minute that there are ways to kind of sift through that mountain of violations, those thousands of violations, at a top level or at a viewpoint that a manager or a compliance officer might see, and we're going to do that through the reporting functionality in DTP.
Okay, so let's talk about that. Now that we've got the tool, you know, we've picked out which checkers we want, we've configured them, we've set up specific policies and patterns to really look at the code that we care most about. Now we're going to start looking at, what do I do with the findings? And I see a question just popped up, and I'm going to go ahead and answer it right now, asking if the tool can be connected or linked with other development tools like Jira or Doors. And the answer is yes. We're going to talk about doing that the right way in just a moment, because it's an easy trap to fall into. So yeah, the right findings. Static analysis has a reputation for producing mountains and mountains of let's just call it noise, right? Like so many things. And basically part of this problem is people are looking at what's coming straight out of the tool, right? They're not putting this effort into selecting the checkers, tuning the checkers, tuning the configuration against the code, against legacy and things like that. And the funny thing is that when you talk about finding straight out of the tool, there's an acronym for that. It's called CERT, okay? And CERT looks like this. And if I have this giant mountain of coal dust, the problem is that static analysis has actual really, really valuable pieces sitting inside of it. There are gems and diamonds that I really, really want to get. And I don't want to dig through this whole pile. So I'm going to use various techniques to help me sift this thing. What I really want to do is use, you know, forms of prioritization to funnel this so they get a much smaller amount coming out of the bottom of it. So the primary mechanisms that I will use will be things like severity. We've talked about that already. About risk, about history. We did have another question here about, could I have just run this, and it looks like we've answered it. Yeah, there are different mechanisms that we use before we execute versus post execution, so we can certainly filter all the results. There are different reasons you might do that, but it's important not to think about just filtering results when you're not yet running the right checkers on the right code. So filtering is a great exercise once you have the right configuration in terms of checkers, in terms of legacy code, etc. After that, filtering is a better thing, and filtering might take into account severity. It might also take into account things like deviations and suppressions. You might have a particular checker that doesn't apply in a particular function or module. You might have just a specific instance of a specific checker. You have lots of different ways that you might suppress a finding or deviate from the standard, both really being the same thing. And so that's one of the ways. And using persistent suppressions, persistent deviations, means that you look at this thing one time, you say, oh my gosh, this module, this checker just doesn't apply to this module, even though it applies everywhere else. Maybe it's an old module and it's highly optimized or highly risky. And so you document that, and the tools remember it and never bother you with it again. So it's a really powerful mechanism, but it is human driven. Severity, typically tools have multiple severity risks. We happen to use a SEV 1 through 5, where 1 is the most nasty. I like to think of it more in the context of like POSIX definitions. So critical, high, medium, low, and informational. Critical meaning I'm fixing that thing right now, right away. I'm going to issue a patch, whatever I can do to get this fixed. High meaning I'm definitely not shipping the new product without this fix. Medium meaning, hey, this is kind of important, I should look at it. And below that, honestly, I don't actually have time for those other ones, okay? But that's just reality. Risk is another interesting way that you can really trim these things beyond just severity. And we're gonna look at some risk models that are built into some of the coding standards, because the risk models aren't just about a generic, oh, this is severe, but this is severe because it's easy to find, easy to take advantage of, frequently happens, and things like that. So it's pretty interesting, as well as the impact. So having this secondary setting, you know, high, medium, low, can be very helpful for filtering things out. But also, risk is an easier thing for the business to understand. If I go to, you know, my manager and I say, hey, we've got some integer overflow issues, should we deal with this? They don't really know the context of that. Where I might say, well, this integer overflow can lead to a denial of service or a lack of availability. Do we care about that? And they can make an informed decision about whether or not they should hold up a release for it. So risk is really interesting. And some of the models that are out there, these aren't, you know, Parasoft's research. This is just us implementing risk models from other people. The one you see here is CERT. I like CERT. CERT is a great standard because it's great for security. It's great for engineering, safety, reliability. So it's kind of, you know, like one standard that lets you do lots of different things. And the cool thing is that they took 3 basic pieces of metadata around each particular checker, or in their case, they're a guideline, right? The checkers implement the guideline. And one is severity. How serious are the consequences, right? And they've actually well defined them. You know, low level is denial of service. A high level is being able to run arbitrary code. They've also taken into account likelihood, meaning, you know, this is external, someone can get at it, they can reach it, and when they reach it, it's, you know, relatively plausible that they can do something with it. And again, they assign a value 1, 2, 3, and then cost. And cost is interesting because sometimes when you look at a vulnerability, you might say, hey, this thing is, you know, really, really hard to repair or hard to work around, and maybe it's unlikely. And it might not just be a security vulnerability. It might be a performance issue. It might be a reliability issue. It might be a safety issue. And you just look at it and figure out, you know, what is the cost of, you know, rewriting this whole piece of code. And again, you get a 1, 2, 3. You notice this one's backward in that 1 is high and 3 is low. And the reason is that we multiply these 3 values, and that gives us this little target at the bottom. So the things that are high severity, very likely that a problem is going to occur, and cheap to mitigate, end up in the middle. So it's a super easy way of filtering based on research that people have done against these existing coding guidelines. OWASP has a model as well. It's kind of cool. It's a matrix instead, little different bits of metadata, exploitability, the prevalence. Do we see this in the real world? That's what they mean by prevalence. Like, how often is it actually happening? And detectability, meaning because they're focused primarily on security, they're saying, can someone figure out that this thing is there and exploit it? And then they're using technical impact. So again, like, what happens or what are the consequences? And then they have this little, you know, red, orange, yellow. Is it high, medium, low? And the real critical ones are actually ones that run across that top row in red, where they're easy to exploit, common, easy to detect, and have a severe impact. Those are where you would start. And we'll show you a way to do that in our tools in just a moment. There's also this other interesting thing around technical impact. There's a system used by CWE, and as part of their common weakness scoring system, or CWSS, it's related to an ISO standard called 27010. And basically you see these different buckets that talk about impacts. And so I can see that any kind of a problem in software should end up in one of these buckets. Maybe it's operability, maybe it's efficiency, maybe it's reliability, maybe it's security. And so with these different buckets, I can start to understand again, okay, I have this static analysis violation and it's a security problem. We have a security initiative, I should fix it. Or it's a portability problem, and right now we're running on a single platform, so it's not important. 6 months from now, we might be migrating from 32-bit to 64-bit, and portability might become our #1 problem. So having these impacts based on 27010 can really, really help things. The blue boxes, for those of you who've got a little bit of OCD like me, you'll look at this and go, why are some of those blue? The blue ones are the ones that are currently linked to CWEs. So it's cool because CWE has already implemented these, and because of that, Parasoft has implemented these things, so you can see them. So let's take a look at that, Brian.
So we're going to return here to DTP one last time, and what we see here is a dashboard for the CERT compliance standard. So I mentioned that DTP is an aggregation tool for all of those static analysis violations. This is kind of what it looks like. So this is just one of many dashboards that we have available. We have a wide range of pre-built ones across all of our supported standards and languages. But most of them look something like this. It's a set of widgets which display your data. And these widgets are all completely configurable. You can move them around. You can get into them and edit the information that they're actually displaying. Or you can add new ones to the dashboard. Maybe there's something that's not here that you do want to see in part of your overall view. And kind of the coolest thing about these dashboards is that all of the information you see displayed, all of anything that's graphed, you can drill into. So let's, for example, just say in our tree map here, it looks like our int31c violations are kind of a large portion of what we reported. So let's click and drill into that. And this is going to take us to our Violation Explorer. And this is kind of a filtered view of what we saw in that top level of the dashboard, right? It takes all of your violations and they've been trimmed down to the int31c rule.
And Brian, I just want to say something at this point because I don't think we mentioned it earlier, but where we have a static analysis configuration linked to a supported specific standard like CERT or MISRA or OWASP or CWE, we've actually implemented this in a mapless way or a standard-centric way. So you see there a checker called cert-int31_C, and if you went to the CERT website, you would find a category called int and a guideline called 31C, meaning it was for the C language. So we've taken all that question out of it. In fact, if Brian went to the docs like he showed you before, you would actually see that link to int31C down at the bottom. So just kind of cool. We've taken that whole concept of maps away from you. You don't need them when you work with these, big supported compliance standards.
Right, you know exactly what you're checking against with every checker that you enable for these standards. Back to Violation Explorer, we see all of our int31c rules, and we've got a lot of good information on any of these violations that we select. We can see exactly where it's been triggered here in the actual source file, so you can get context around the violation. But maybe the most powerful tool in Violation Explorer here is in the bottom right, and it's our prioritization. This is where all of the human triage is going to happen in DTP. This is where you can assign specific users to resolve the violation. You can suppress it if it's something that we've deemed unnecessary or not related to the application. And we can set internal priorities, actions, and risk and impact. So going through all of these, thousands and thousands of violations, if we know exactly which ones we want to find that are critical and extreme risk and impact and set those to fix, we can do that. So let's say, management or a team leader has gone through these violations and set all of the critical and extreme risk impacts that we need to fix. So we can edit our filter and take a look at the critical priorities, the extreme risk and impact, and all of the actions that have been set to fix. So we've trimmed down those thousands of violations to 3 critical priority, extreme risk impacts that we need to fix right away. And this is something that the developer can use, right? They've got all the information here that they need to fix the violation. They've got the source code, modification and violation history. They've got the same documentation that they had in the test configuration editor, which is also available in the IDE. So this is kind of something, this link can just be sent straight to a developer, for example. Hey, fix these violations. They're critical, they're high impact. And that's kind of all that needs to be done, right? That we've trimmed it down to something that we can finally actually triage and resolve in the source code.
And it's really interesting here because we've shown you like 2 different UIs that fundamentally fit different people well. And we'll talk more about that in a moment. But, you know, the developer typically works in, you know, Eclipse, IntelliJ, you know, Visual Studio, things like that. They work in a place that's designed for editing code, whereas the manager might want to see the file, but doesn't necessarily need to have the source code on his or her system, and doesn't want to set up the build or anything like that. So it's really cool to have these different UIs that support different use cases. And also that this data, like this might have come from a CI build, but you can actually round trip this back into the IDE on the desktop that I mentioned before. So Brian could just import these results even if they weren't run on his system, which is really cool.
Right. And I want to show one more view here back from this CERT dashboard. And it's the bullseye that Arthur mentioned earlier, the CERT levels, where the outer ring with 1,500 violations is there may be hard to fix and low impact. The middle ring, which has 7,100 violations, which is quite a few, we'll probably need to get into that sometime, is kind of middling severity. And the inner ring, they're very severe, but they should also be easy to fix. They're kind of on that fixed first basis. And of course, like everything else in this dashboard, we can drill into it. And since this is a compliance dashboard, it's going to take us directly to our CERT compliance report, which can be kind of downloaded at the click of a button for the compliance officers out there. But we can see kind of what rules that we've run that are compliant or not compliant, or kind of compliant within a level of violations. So kind of we can see the ENV 32 and 33 we're compliant with, but error 33C here, we've got 1,359 violations. So maybe for this one, we want to think about if this is a rule we want to be running, and if it is, we might be in trouble here. But this is kind of just another view for another role that is provided by DTP, and DTP is very good at providing information to a lot of different roles throughout an organization.
Yeah, so let's now look at the last couple of things here. And one is this concept of personas, right? Different people have different needs when it comes to static analysis. And there's 2 or even 3 or 4 roles, but I've got 2 basic buckets here that really matter. One is the developer. And the developer needs to know who's supposed to fix this, right? You saw that we had a way to assign things. We typically get that, you know, the default is the person who owns the code, wrote the code, touched the code. You might be taking over a piece of code. And so you need to think about what happens when people move or leave, because I could have gone into that UI and bulk filtered based on Brian's name and said, okay, everything that was assigned to Brian is now assigned to Arthur, and I'm going to take over all of his stuff. And now it shows up in my list. So the developer really needs things that work that way, and also in the IDE where the code is, so that you can take a particular violation. You want to be able to right click it, look up the docs, get information, see what builds it's in, but you also want to be able to just double click it, have it open the right file, take you to the line of code, highlight it for you, and let you go. So the developer's typically looking at very tactical information. What do I need to do? Where is it? How can I quickly get there? And why is it that I'm looking at it potentially? The manager needs to see these trends, these reports. Am I in compliance? Am I not in compliance? Am I moving? And, you know, am I making progress? Am I making reverse progress, right? What's working? And be able to set up dashboards and things like that. The daily tactical information may be not so important. There's also a compliance person in some cases, right? If I'm doing automotive, at some point, I'm going to have to roll this thing up. It's going to have to exist as part of my ISO 26262 filings. And so I'm going to need various different compliance reports. And the person who's doing that probably doesn't have Eclipse, IntelliJ, source code, anything like that. And their job is simply to run around and gather reports from people. And so there's some interesting things we can do to help them as well. And that's making sure that the data that comes out of the system gives everybody what they need. So again, when I look at the developer role, I can get my results here in the bottom right, just like I normally would from a compiler or other tools. If I double click a line, it takes me right into the editor in the middle. I can check files in and out and update things and all the sorts of normal things that developers do. The managers are looking over here more at the you know, the dashboards, the widgets. I can see, you know, this top one, there's a lot of green. It looks pretty good to me. I am not in compliance currently, but I can see in the second widget on the top row that the amount of red is small. So even though my binary widget says you are not in compliance, my next widget over tells me, but you're not very far from it. In fact, there's a couple of widgets on here that have some actual percentages, and you see that, you know, we're 97% compliance, so I might not be too worried. So these are the kinds of things managers need to know to understand. The tree map helps me see hot spots in the project, etc. And again, one of those things that you need to think about here is, if we are doing static analysis because of a coding standard, you know, MISRA for automotive, JSF for aircraft, DO 178B, UL 2900, I need to make sure that the static analysis tool is actually covering the standard. And again, it's all too common, especially open source tools might cover 10% or even 50% of a standard, but they don't cover the entire standard, and they don't necessarily tell you which parts of the standard they cover. This is why we had this mapless implementation, so that we're very transparent about exactly what we cover. And when we're reporting, you don't have to create special reports that try to map, oh, that violation from that funny Parasoft checker is this funny item in this particular standard. Standard-centric reporting and auditing. And we've implemented these risk models. Again, you see the CERT one here at the top. On the bottom, you see, actually starting from the right, you see the CERT risk model, you see the CWE technical impact model, and you see the OWASP risk model. And that CWE one, we didn't click into it, but you see the kinds of impacts. It's very granular, so I can see that maybe things read files or directories or execute unauthorized code. So there's some really cool impacts. And again, now at a business level, I can say, man, I don't want people being able to execute unauthorized code in my application. So it's interesting. I mentioned compliance audit-ready reports. This is one of those things, again, people spend a whole bunch of time toward the, you know, the end of a release, the end of a sprint, or you know, when an audit is coming up. So the things that you need like a cover sheet, an overview, a detection plan, meaning what things did you do for what things in the standard, right? Again, this is that mapless implementation. Instead of saying, well, I'm running CWE or I'm running MISRA, what particular Parasoft checker did I run for what particular MISRA guideline? And the tool reports that way. So your detection plan is A equals A kind of a thing. It's pretty simple. Deviations have to be documented if you're in a compliance environment. And your build audit report. When did I run? What were the results? So that I can prove that I actually did something other than just have a tool. Now we have the single button that you can actually click. And I like to think of this as compliance nirvana, right? Like I don't have to go around, gather up reports. I don't have to go to find funny places where I'm going to find these reports. I don't have to beautify them all at the end. By the way, any report in Parasoft can be exported, can be saved as HTML or DTP, depending on what you want to do with it, or a PDF, sorry. But this really cool one, and you might have seen it when Brian was doing his demo, but it's over there at the right when you clicked on something. It pulls them all in one big stack, and boom, you're done, and you get all your different information. So it just makes life so much easier. So one other thing here, now that we've getting the right information, the right data to the right people, is running at the right place and time. And I mentioned in the beginning we were going to talk about this. This is really, where do I run this? Do I run this on the desktop? Do I run this as part of a CI/CD build? Again, to me, ideally, I'm running on the desktop just because the quicker I get information back to the developer, the easier it is to fix the problem. There's a Capers-Jones graph that we show all the time from his work about the cost of finding a bug. And as you find it earlier and earlier, as you shift it left, it becomes much, much cheaper to find and fix bugs. So I prefer that it's running on the desktop, but I don't like to block things on the desktop. I like the desktop to be potentially the right configuration, but it's simple, it's fast, it's lightweight. And then again, this trust but verify that I mentioned earlier. So essentially, I'm using the desktop to find problems and I find static analysis violations and I fix them. And in theory, my CI/CD, automated build, etc., is validating that they are fixed, that we are in compliance. I'm not typically expecting the CI/CD system to find static analysis problems. There might be certain cases that you need to do it, but in an ideal, like a perfect engineering world, when we think about how manufacturing improves things, the CI/CD static analysis execution would be a proof that you were in compliance, and the desktop execution would be a way to find non-compliance. So that's how I would normally do it. The CI/CD build, we have different integrations with different tools. Some of them have plugins, some of them we have some graphical integrations, and we have some CLI stuff. So you see here, like we've put graphs up into Jenkins, and you can set up these funny builds. And the CLI is there just because a lot of our clients, doing interesting embedded things and have some really specialized systems, or maybe they're running on tiny targets and traditional build systems just aren't appropriate for them. So the CLI lets you integrate with just about anything that you could ever think of. Another integration that I just wanted to talk about, and I think it's going to show up in our common traps, actually. I'm going to hold on this for just a second. We'll come back to it. Common traps. What mistakes have we seen people make? And this is pretty interesting. I've been helping people deploy static analysis for over 2 decades, and some of the really, some of these are trickier than you think. Well, number one, analyzing code that you won't fix. This sounds really obvious, but think about, for example, a piece of legacy code where, as I mentioned before, your policy is don't touch this unless a field bug is reported. So I'd ask myself, why am I running static analysis on this? If I'm not going to fix it, it's just something that I'm going to have to go and filter and triage and mark up and make sure it doesn't show up in my compliance and audit reports, etc. So if you don't expect to fix something, don't look for something there. It seems logical to me. Little stepsister here, running checkers you won't fix. This again seems silly. Like, why on earth would I run a static analysis checker that I don't like? But people frequently do. And there are some tools out there that have small numbers of checkers, and so people don't think about configuring the checkers. There are some tools out there, even commercial tools, that don't allow you to configure the checkers, so you are running checkers you won't fix. This is not ideal. Ideally, you would look at a checker and you would say, okay, I read it, I understood it, and I still say that it's not important for me here in this context, in this time and place, and it's just not going to be important for our organization or our project or this file or whatever. Again, if it's just creating noise, you just shouldn't be doing it. Blocking the check-in, that's the one I wanted to cover. It's part of that desktop versus automation thing, but there's 2 halves to this. One is I could put a hook, and I've seen a lot of noise recently about somebody claiming they have the first static analysis tool that lets you hook into your check-in system. Well, that's bunk, right? Like, that's been possible with any static analysis tool for as long as there's been static analysis tools, because check-in tools allow hooks so you can execute. This is not necessarily a wise thing to do unless you're in a very strict compliance environment, like a safety critical environment where loss of life is impending, because it really impedes software development. Again, if people are used to relying on code being highly available in an agile world, we're running, continuous builds or hourly builds, then I really don't want to block the whole system up, especially because I've got static on the desktop and I have it in the CI. So if someone doesn't run it, I'm going to catch them. And that way I'm not impacting particular individuals. So it's one of those things, maybe don't block people. The other side of that coin is turning static analysis violations into bugs. We had a question about that earlier, and that is one of those things. Can you do it? Yes. The reason that we don't build the tools to do it by default is that, think about that project that Brian was running on initially, and we had 1,300 violations. Can your system handle 1,300 new violations for your project that previously had 150? Like, it's not appropriate. And a lot of them he filtered out for rational reasons. Maybe severity was too low. Maybe risk was too low. Maybe impact was not relevant. Maybe the code was old and subject to a policy that it's not supposed to change. So until you have your configuration perfectly tuned, there's no way on earth that you would want to do this. And even then, it can be very problematic. So it's one of those things that it sounds like a really cool idea. If you're used to a tester, and so you're thinking about a test failure, creating a bug automatically, that makes a lot of sense. But static analysis isn't just testing, it's analysis. And the results of analysis aren't necessarily bugs. The result might be that you should go look at a thing. So it's a risky thing. If you have a particular, again, if you're in a strict compliance environment, I might change my tune here once you've tuned it right. But you might want to have a static analysis configuration where you've gotten it really just right, and your policy is that there should be no violations other than allowed documented deviations or suppressions. In that case, I might turn the entire static analysis output into a single bug when it wasn't succeeding, and that wouldn't really mess me up, again, in a strict compliance environment. Another one, this is funny, it should make you laugh, turning on all the checkers. Look, we have thousands and thousands of checkers available. If you turn them all on, first of all, it's going to make you crazy. Second of all, some of them are warnings and informational, and they're only important in a very specific context. And if that context doesn't apply to you, it might not matter to you. The interesting thing is, because we support lots of different standards, CERT, CWE, MISRA, Joint Strike Fighter, DO-178, PCI-DSS, UL 2900, sometimes they conflict with each other. In a perfect world, they wouldn't. We have seen that more and more smaller coding standards are starting to rely on existing standards like CERT, MISRA, and CWE. I look at them as potentially the big winners in the future. But just don't turn on all the checkers. Turn on the ones that you care about. If you feel the need to turn on all of something, turn on all the critical checkers. Start there, right? And much less likely to have a problem. And then noise and false positives. Again, if you just run and then you figure you're going to triage everything, that's madness. Getting the configuration right is the single largest thing that you can do to reduce noise and to reduce the perception of false positives. Recognize that most of the time when a developer calls something a false positive, it's not technically a false positive, it's a finding they don't like. And they don't like it because they don't like the checker, because it doesn't apply at that line. A true false positive, meaning that the static analysis tool actually got it wrong, is actually not that common. Noise is the big common problem, and improper configuration, improper policies based on legacy code, improper training where I don't understand why something's important are all the biggest issues around this. So in summary, get the right config. Make sure the checkers enable are the ones you care about. Suppression or deviation comes last. Triage comes last, not first. Workflow and policy are both super important to getting this right. And prioritizing based on severity and risk is going to help you reduce that. We saw in Brian's case, he was able to trim 95% of the violations before a human had to get involved. Watch out for legacy code and make sure that you're dealing with it. The Parasoft tools are extremely flexible in dealing with at the line level, file level, function level, module level, checker level, severity level, etc. So you can really configure the tool to do exactly what you want. And if you find that you're triaging too much, it probably means you've configured improperly. It probably doesn't mean the tool is noisy. It means that you turned on more than you needed to. And reports should be meaningful by role, as we've shown, and in the right client. In other words, output needs to go inside the IDE. Email is not a development environment. Excel is not a development environment. You shouldn't gather up static analysis results into an Excel spreadsheet and deliver it to a developer. You might gather them up that way and deliver it to a compliance officer or a manager, but that's not what a developer needs. So one quickie thing, you can get this chart from us, send us an email and ask about it. Oh, by the way, the slides and the recording will be available. We'll send you all an email the next day or so. This is a checklist based on the 5 basic categories of static analysis tool features. And these are things that I expect modern static analysis tools to have. So if you want to read a longer paper about getting the right tool in the first place, certainly, again, let us know. We'll send you that link in our email with all this other stuff. So with that, we took a couple questions live there. We're kind of at the end of the hour here, so we thank everybody. If you want to try the software out, go to parasoft.com, software.parasoft.com/try, fill out the form. And right now, during the pandemic, we have lots and lots of free webinars on lots of topics for you. So please check out parasoft.com/events, sign up for the other events. If there's a topic we're not covering, please let us know. We're happy to add a webinar to it. And with that, thank you everybody for attending and have a great day.